Welcome to our presentation. Our topic is stream cipher and block cipher. Here is our outline. For the first part, I will discuss stream cipher. The stream cipher is an encryption algorithm that encrypts one bit or one byte of plain text at a time. It uses an infinite stream of the pseudo-random bit as the key. As it is a very simple algorithm, I will introduce some examples. The first example is called one-time pad. It is the most easy encryption technique of stream cipher. The key stream of the one-time pad has the same length of the plain text, and it can be only used once. Due to these two attributes, it cannot be broken by any crackers. It has been widely used in military communications. However, the problem of the security key distribution has made it impractical for most applications. The second stream technique is RC4. It is the most widely used stream cipher, such as in WEP, WPA, SSL. It runs fast in software and hard to be broken by cracker, but the implementation is very easy. It contains two important parts for generating key stream, key scheduling algorithm and pseudo-random generation algorithm. From the block diagram, we can see after these two algorithms for generating the key stream, it XOR with the plain text to generate cipher text. From above discussion, we can find the disadvantage of stream cipher is that it is very fast and easy to implement and has low error propagations. However, the disadvantage of the stream cipher is it has low diffusions and open to attack you rather than breaking the keys.
Now let's move on to block cipher. Block cipher converts each block of plain text into a block of same-sized cipher text with a symmetric key. For most block cipher algorithms, they use iteration in encryption and decryption. Iteration refers to run that repeats the application in an invertible conversion. There are two famous iterated block ciphers. One is substitution permutation network that applies alternating runs which uses substitution and permutation to yield a corresponding block of ciphertext. Another one is Feistel network, referring to dividing a block of plaintext into two same-sized parts, applying round function to one part with a subkey and then XORed with the other part, then swap two parts and repeat the operation. One advantage of Feistel cipher is its round function doesn't have to be invertible. Two famous examples are DES and AES. DES is one of the earliest block ciphers. It was widely used before. It can be run on economical hardware and its throughput rates are very high. AES appeared and it was adopted by US government in 1998. It performed more safely and fast in both software and hardware. AES abandons Feistel network and uses a variant of Randall. Its block size is increased to 128 bits with three choices in different key sizes. More bits the key has, more rounds the cipher has. For block cipher, high diffusion is one of its advantages. Another one is integrity protection. It is possible to detect illegal symbols inserted by the attacker since every bit will affect the final ciphertext. However, the low efficiency is one of its disadvantages. Block cipher can only deal with the plaintext in blocks of a fixed size, which wastes time in appending the plaintext to a multiple of block size, and storing the results needs more memory. Another one is it is more susceptible to noise in transmission. Even one part of data is messed up, all the rest is probably unrecoverable.
Based on the points and the cons discussed above, the hybrid algorithm to combine the characteristic of two cipher modes came out to improve the encryption algorithm because it is more difficult to break the hybrid one. String cipher tend to be faster and easier to implement in hardware, and the string cipher built from block cipher can often be more efficient than block one on its own, because in most cases, the decryption is not needed. Building string cipher from block cipher can be a useful alternative, such as ECB and CFB. Building string cipher from block cipher. For CFB mode, a block cipher is used to build a self-synchronizing string cipher that provides confidentiality. One approach to improve the efficiency of CFB is to reduce the round size of DES in CFB mode, which allows an attacker to gain knowledge of several key bits via differential or inner attacks. Here is another example. Firstly, when an cipher is a typical string cipher, the main disadvantage is that it's not feasible to generate and share a key, that is, as long as the plain text message. They are more difficult to implement than block ciphers because the key string cannot repeat itself during the session. On the other hand, block cipher adds the sort into ciphered blocks in the encryption and removes them from the ciphered blocks in the decryption. As a result, they decide to use the counter mode encryption and have one sort for each block guaranteed one-time pan of the winner cipher, and that the same message, equipped with the same key twice, will not produce the same ciphered message, because sort would be different for most of the blocks.
Hybrid chaos-based image encryption is a representative application of the combination of block and stream cipher. In multimedia domain, we always want to preserve the structural information of the media files and allow viewing the files in their encrypted state. So we get partial image encryption instead of standard encryption. But the drawback is lower security and increased file size. Then hybrid encryption is proposed. This encryption strongly encrypts the most significant frequency bands and encrypted other parts simpler so that better compromise between security and file size can be achieved. Chaos-based encryption uses multiple chaotic maps and is mostly based on the XOR, a circular shift and positions transposition operations that is made with the help of position generator. A positions generator is needed because the positions of pixels and pixel bits will be shuffled many times during encryption. The encryption algorithm includes 3 steps: a pre-encryption process to rearrange pixels and spread out the bits. The image is divided into 2 parts and each one is encrypted in different cipher, and finally merge them together. In pre-encryption process, 2 simple rounds of diffusion and an image pixels transposition are made on the original image. The diffusions are right or horizontal diffusion and left horizontal diffusion. After these diffusions, pixel positions are modified using positions path generator. In step 2, the image is divided into 2 parts. They share the same height and weight at first. The first part is encrypted by stream cipher and the second is by block cipher. Finally, the sub-images are placed in the ciphered image in the even node positions. The decryption procedure is similar in reverse way to that of the encryption process given above. This algorithm performs fairly well. The histogram is uniform and completely different from the original image. Adjacent pixels have no correlations. Extreme sensitivity on the plaintext, not vulnerable to the differential attacks. The original image cannot be recovered even there is only slight difference on the encryption and decryption keys. Thank you for listening.